you have to include all four of these lines. Okay? And this whole thing together means as x goes way, way, way to the right, y goes way, way, way up. And this means as x goes as far to the left as you can imagine, y goes up as far as you can imagine. And to say touchdown, you have to include all four of these lines. This is a rare case, actually. I normally consider math to be the most efficient sort of language ever imagined, ever created. But this is actually a little bit inefficient. You have to write four things to get this one idea down. Okay? So to say touchdown in the correct math notation, you have to write when x goes way to the right, y goes way up. When x goes as far to the left as you can imagine, y goes as far up as you can imagine. And these four lines combined mean touchdown. Okay? So now, coming over to this board, if I want to describe a marionette, as we called it, okay? Picture a marionette. It's a function where the ends look like this. Might have a bunch of curves in the middle, but the ends look like this, okay? So you can picture this in your head. I'll draw it at the end, but as x goes as far to the right as you can imagine, that's your right over here. On a marionette, what is y doing? Going down. How long?
As
far as you can imagine. Negative infinity. So as x goes away as far to the right as you can imagine, y goes down as far as you can imagine. Now this only describes this half of a marionette. How do you think I described this half in math?
As x goes to negative infinity, f of x goes negative infinity.
Yep. And these four lines in math, in these two kind of pairs, this is like a dependent clauses in grammar. I'm going to mess that up if I try and make that analogy. Okay, if this, then this. It's like an if-then statement in geometry. If x goes way to the right, y goes way down. If x goes way to the left, y goes way down. That describes a marionette. Now this only describes the behavior way out at the ends. In between, this could easily describe something that goes up and down further, and up further and down. But if at the ends, this is what it does, then these four lines apply. Yes, Artur?
Which side is which?
As x approaches infinity is always to your right. As x approaches negative infinity is always to your left. We're looking at, this is positive x going out to infinity. This is negative x going out to negative infinity. This is positive y going up to infinity. This is negative y going down to negative infinity. Okay? This notation gets very, very important for those of you who make it to a calculus course in your life. It gets vital. College calculus, you spend literally the first 2 months looking at notation like this. I'm not teaching it here at the moment. Yes, I learned it. I taught it for 9 years at my last school, actually. And then I taught a college calculus course too, so yeah. I know a little bit of it. Just a little bit. Okay, that's touchdown and marionette. Now you guys can help me, I hope, fill in the next two. Which are, hang on, actually, Nimi, I asked you to hold off on a question. What was it?
Well, my question doesn't relate to any of this.
Okay, thank you. Keep holding it then. Jordan, do you have a question that relates to some of this?
It relates to math.
Okay, great. Hold those. What are the next two we haven't done yet? We did touchdown, marionette, ballerina.
Is there going to be an infinity ballerina?
Yes, picture your ballerina. Okay, picture your ballerina. Please get all confetti and pieces of paper out of your hair first. And then, on the ballerina, as x goes as far to your right as you can imagine, what does y do?
It goes as far
to the right.
Up, up. Y is always up. X is always left to right. Y is always up.
Wait, I don't get it. It's all doing the same thing.
No, you got to look very carefully at the positive and negative sign, sweetie.
I honestly, I don't know.
Okay, positive. When you talk about x and positive infinity, Jordan, you're talking about going to the right. You're right. On the coordinate plane, you're talking about going way out here on the x-axis. When I say as x goes to infinity, I'm talking about going way
We're all
out.
doing the same thing now. We've already done the exact same thing.
Nope, we've had different positive and negative signs by the infinities.
So what is f(x) and f?
x is left and right, f of x is up and down. That's the simplest way I can say it. Okay? So as x goes way to the right, y goes up. That's what a ballerina does with this arm. Ballerina function.
Well, then where's the x going to the right? You're pointing down.
Your right, my left. I'm mirror imaging it for you.
I always remembered that
You're
because the
welcome.
Y.
Okay.
No, wait, but that doesn't make sense because then something would have to go to the left.
Here, I'm going to draw it. Okay?
I've always remembered the X and Y axes because the Y is as a tail and it's like it's reaching down.
That's
So it
interesting.
reaches up and down.
That's interesting and a little weird. Okay, Jordan, here's what a ballerina looks like, right?
Everything.
Okay, this is to the right, this is to the left.
Yeah, but nothing.
Okay? As x goes to the right, y goes up. That's the description of this part of the ballerina graph.
What about the bottom?
Here's the bottom. That's what I'm going to do now. As x goes to the left, which I represent by negative infinity, y, which I call f of x, goes down, which I represent with negative infinity. If you look carefully at all the positive and negative signs, they're different on each one, and they represent left or right when we're talking about the x's, or up or down when we're talking about the f of x's.
Wait, can you do reverse ballerina real quick? I just want to see
They're
the
writing the same thing.
side of the chair.
The drawing real quick?
Yeah.
Yeah.
Just wanna-
Here's the reverse ballerina drawing. This would be the y equals negative x cubed,
Wait, no question.
but
Like, not to be difficult.
Yeah.
But seriously, that and that is the exact same equation.
nope.
Yes, it is.
Here's the difference.
It's one negative.
X goes to the right, y goes up. X goes to the right, y goes down because of that negative sign.
Then everything else is the same.
X goes to, yes, that's correct. That's because, let's say you have the simplest marionette graph, this one, y equals negative x squared. Okay? This side of this graph behaves a lot like this side of this graph. So they're describing the same behavior. Okay? So now we have reverse ballerina. Brian, you asked me to draw this. Think you can tell me what the math is?
Yeah. X goes negative infinity.
You want to do the left side first?
What?
You want to do this side first?
Yeah.
Okay.
X to negative infinity, and then f of x to positive infinity.
Yep. Brian's saying as x goes to the left, y goes
Do the
up.
other side first.
You just did the.
I'm gonna, for consistency, Brian, I'm gonna write it down here.
Alright, that's
It's
fine.
infinity is so many.
It does take some getting used to. It's a sideways 8 if that
So I
helps.
keep having to look
Okay,
at
so
it.
now Brian, what happens as x goes to the right?
And then that'd be positive infinity,
Yep.
and then f of x to negative infinity.
Okay, so from now on, this is gonna be one of the ways I will ask you to write the concepts of marionette, ballerina, reverse ballerina, and
Like this.
touchdown.
That instead of this.
With this notation, yeah.
Yeah, instead of this.
Yeah. I'm asking you to mix and match. I may let you do both. We'll figure it out. Today now I've got to talk about something new, adding, subtracting, and multiplying polynomials.
Oh, great.
Really?
I know, 10 days off
Make it
bites.
more
No,
complicated.
I don't
Like,
even get, I mean, even if I do this, I don't know how to do this with all of them.
This, some people find this actually easier, what we're about to do
It's
next.
funny the difference between like the way we're doing this here, the speed we're doing it, and the way we did it in public school. It's just
I'd love to discuss the details on that.
it's just better here.
Well, thank you.
Okay.
It's not because of you.
Not at all. No, it has nothing to do with me, I know. I don't take it personally.
It may also be because it's the second time I'm taking the class.
That may have something to do with it.
Mrs.
Okay.
Phillip,
Yes.
Really?
Really?
Snap.
Can you give some time to go over the one project?
I hope so. I truly hope so, but I'm not sure. Okay, adding polynomials.
I thought you said multiplying dividing.
We're doing adding, subtracting, multiplying, and dividing them, and I've got to do adding and subtracting them a little bit quick. Again, this snow has really messed with things.
Did we already do that?
No, I don't think so. Hang on, slow down. Wait and see first, then have judgments. Okay? All right. Assistant Director of Photography, thank you. Okay, now adding polynomials is adding like terms. Okay? Adding like terms. Terms, we said yesterday,